Hi, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This is a video for grade 9 academic students and it's the third video of me taking up some measurement questions and it's by request. So this is question number 8 from the homework. It says the Cutie Cupcake Company is having a sign made. The sign will be a semicircle on top of a trapezoid. What is the total area of the sign? So this is another composite shape question. And to deal with composite shape questions, you want to sort of visually cut them up into their pieces. So for example, this is a semicircle. I'll call that shape number 1. And shape number 2, well, it kind of depends on you. If you see a trapezoid, awesome, because we have a formula sheet that tells us the area of a trapezoid. So that's definitely going to be the easiest way to do the question. Of course, some of you may have wanted to cut this up into 2 triangles and a rectangle. Perfectly fine. It just will take you a little longer to do the question. Let's do the area. So a semicircle. The area of a circle is pi r squared. So a half circle is pi r squared divided by 2. Now what's the radius of the circle? So radius is halfway through the diameter. And let me clean up my diagram so we can clearly see. Yes, this 2-meter marker is clearly halfway, is labeled halfway through, and that must mean it's talking about the diameter. If it was talking about radius, it would be labeled over here, and you would see a dot in the middle to clearly indicate a halfway point. So 2 meters must be the diameter, so I have to take that, cut it in half, and get the radius equal to 1 meter. So that means Cutie Cupcake Company, that your semicircle has a radius of 1. So let's do this math. Pi r squared divided by 2. That's going to give me about 1.57 meters squared. And now let's talk about the trapezoid. So the area of a trapezoid is a plus b times h divided by 2. And a plus b are the length of the 2 parallel sides. So here's the 2 parallel sides, and one of them is length 2, the other is length 1. And the height is the perpendicular distance between those parallel sides, so my height must be right here. So substituting all of this into the formula, we get area equals 2 plus 1 times the height divided by 2. And that's just the formula. It's on your formula sheet. So 2 plus 1 is 3. 3 times 0.7 divided by 2. That gives me an area of 1.125 meters squared for the trapezoid. And so altogether, so total area is 1.57 plus 1.125. And in your answer, round to 1 decimal place. And so I get 2.7 meters squared. Oops, there we go. So a fairly, hopefully straightforward composite area question. Let's look at number 9. Number 9 says the mold shown is used to make a candle in the shape of a square-based pyramid. What is the volume? So obviously square-based pyramid, volume. So let's look on the formula sheet. It says the volume is b squared h divided by 3. B, so in a square-based pyramid, B is the length of the square base. So in this case, the length is 10. H is the height, and it must be measured perpendicular to the base. So in this case, the height is 15. So this is a really straightforward question. All the information we have is directly given in the diagram, and it's just a case of substituting and using our formula correctly. So 10 times 10 times 15 divided by 3, so it's an area of 500 cubic centimeters. A nice straightforward question for once. Let's look at question 10. How far apart are the water fountain and the swings? So it wants this distance here, and they've clearly given us a right-angled triangle. So we're going to be using the Pythagorean theorem, because the Pythagorean theorem is the formula for finding the length of one side of a right-angled triangle. So cleaning up my diagram, this Pythagorean theorem looks like this, and the most important part of using it is making sure you correctly identify what information you have. Here's the right angle. Across from the right angle is the hypotenuse, so that must be C. And that means I'm going to call this side A and this side B. So I know what C is. C is 24. I know what A is. A is 15, and I don't know what B is. So 24 squared equals 15 squared plus b squared. And now I like to immediately isolate the unknown term. So I'm immediately going to say, let's write it as 24 squared minus 15 squared equals b squared. And that way in my calculator, most of you can do this at once in your calculator. 24 squared minus 15 squared. This is why, one of the reasons why you need to have a scientific calculator in high school. So b squared is 351. So to find b, you take the square root of both sides. So in your calculator, what's the square root of 351? I get 18.7. Therefore, the distance from the water fountain to the swings is, oh, why do I keep forgetting my decimal? 18.7 meters. And definitely make sure that your answer makes sense. You know, I mean, the hypotenuse is 24 meters. This is 15 meters, so it's nice that I got an answer kind of in between. Okay, that was pretty fast. Let's look at number 11. It says Zach measures the slant height of a cone-shaped cup and finds that it is 12 centimeters. So slant height, hopefully it makes sense as to what that means. It's the slanty side of a cone. The height is 10 centimeters. Determine the volume of water. So I have a cone and I need volume. So the first thing I do is I look on my formula sheet and I write down the appropriate formula. So the formula for the volume of a cone is pi r squared h times 3. So look at my diagram. I don't know what the radius is. I can't use this formula until I find the radius. How am I going to find the radius? Oh, you see that, right? There is a right angle, and therefore this is a right angled triangle. So we can use, and I'm just going to redraw it here, this right angled triangle, I can use this to help me find the radius. So again, c squared equals a squared plus b squared. And identify properly. Across from the right angle is side C. I'll call this A and B. So I know that 12 squared equals 10 squared plus b squared. Oops. So 12 squared minus 10 squared equals b squared. So in your calculator, 12 squared minus 10 squared is 44. And then take the square root of both sides of this equation. And in your calculator, the square root of 44 is 6.6. So therefore, what do I know? Well, I know that if I go back to my cone, I now know that this side here is 6.6 centimeters. Now I can use this formula. So all of this is important math that you have to show your teacher, but it's not part of the main answer, which is why I've kind of done it over to the side, and I've put a little line here so that my teacher knows exactly kind of, you know, that this is a separate piece of math. It's important, but now here's my main answer. So pi times r squared times the height, and again, the height is the perpendicular piece, so it's 10. Do not use 12 as a height. 12 is not perpendicular to anything. So this is now a calculator question. So pi times 6.6 times 6.6 times 10, divide by 3, and I get 455.9, and it was in centimeters, so it would be centimeters cubed. So generally a pretty straightforward question. We had to use Pythagorean theorem properly, and then we had to use the volume formula properly. Okay, let's look at the next question. Question 12. Okay. Now, with my class, I know that we've done this question sort of on a different sheet, but let's do it again. This time there's more information given. It says when the side length of a square is doubled, the area of the square increases by a factor 4, as the table shows. So the original side length is b, and therefore the original area is b squared. If I instead have 2b, then the area would be 2b squared, which is 2b times 2b, which is 4b squared, which is therefore 4 times as big as it was originally. So let's see how to use the same idea and do this. How will the surface area of a sphere change if the radius is tripled? So let's talk about originally. The original radius is just r. and therefore the surface area, look on your formula sheet, if radius is r, surface area is 4 pi r squared. So my original radius is just r, my original surface area is therefore 4 pi r squared. Now we're going to change it. So the new version has a radius tripled. So in the new version, we're going to say 3r because that's tripling something, is multiplying by 3. Therefore, the new surface area is 4 pi radius squared, and this time the radius is 3r. So let's see what happens. Well, what's 3r squared? 3 times 3 is 9, r times r is r squared. So look what I have. Compare it again over here just visually. I have 9 times 4 pi r squared. In other words, what I have is the original surface area multiplied by 9. So in other words, the new surface area is 9 times bigger than the original surface area. And that's because here's the original surface area, and it's times 9. So hopefully that sort of makes sense. It's some very good math thinking when you can do that question. One more question to go. Number 13. Box A and box B have the same volume. Oops. The cost to make the box depends on cardboard used. Which box uses less cardboard and what is the difference? So obviously if they have the same volume, this is not a volume question. We could certainly check length times width times height, length times width times height. But we don't have to. We can trust that they're the same volume. What we need to find is the surface area, because when you make cardboard into a box, you don't fill the box with cardboard. You fold the cardboard to make the box, and therefore it's surface area. So let's look at box A. Now, every box has 6 sides. There's a top, and the bottom matches it. There's a front, and the back matches it. There's a side, and the other side matches it. So really, there are 3 sides, and each side is doubled. So let's look at side 1. Side 1 has an area of length times width, so that's 55 times 20. And 55 times 20 is 1100 centimeters squared. So now, side 2 also is a rectangle, length times width, and you'll notice, oops, length times height in this case, it's also 55 times 20, so it's also 1100 centimeters squared. Side 3, so side 3 is this one over here, and it's 20 by 20. So it has an area of 20 by 20, so it's 400 centimeters squared. So altogether, if I add up the 6 parts or the 6 sides of box A, I have a total surface area for box A of 2 of the tops, 2 of the front, and 2 of the sides. Adding that up, what do you get? You should get 5,200 centimeters squared. That's how much cardboard went into making box A. Now let's look at box B. So box B, well, box B, if you look carefully, is a cube. Ooh, I love working with cubes because every single one of the 6 sides is exactly the same. So all we have to do is find the area of one side and multiply it by 6. So each side is going to be 28 times 28. So let's talk about box B. Box B, surface area equals 6 times 28 times 28. So length times width, and then there's 6, and they're exactly the same because it's a cube. We love cubes. They're so optimized. And that gives us a surface area of 4704 centimeters squared. And the question said, what is the difference? And therefore subtract. Difference is 5,200 minus 4704, and that gives us a difference of 496 centimeters squared. So I hope that helped. Please post comments if you want to see more work or have me explain something else. Thanks for playing. Bye. Bye.